If you wanted to learn more about the history of the Earth and other rocky planets in the solar system, where would you look? For years, scientists have turned to one of the solar system's most common features, impact craters. Left over from earlier periods of our planet's history, these sometimes giant holes in the surface can teach us about the Earth based on how they've changed over time. However, since even the newest impact craters on the Earth have changed due to wind, rain, snow, and even lakes filling them, we need to compare them to a fresh crater that still looks like it did when it was first created. So where exactly can scientists find a crater like this? Certainly not on Earth, but there's one on the Moon that's just about perfect. The Linn crater, a small impact crater located in the western Mare Serenitatis, is extremely young, and scientists have always thought that it might be a great example to use to compare with other craters. Now, thanks to high-resolution three-dimensional data generated from NASA's Lunar Reconnaissance Orbiter, scientists are sure of it. So why use a crater on the Moon, and why this specific example? Unlike craters on Earth, and even Mars, many moon craters are well preserved because they erode much more slowly. However, despite that, not all moon craters are ideal for comparison. After a crater is first formed, it can be impacted again and again by other objects, which modify its original shape. This is why scientists have been looking for a crater that's not so beaten up, and one that preserves all the telltale signs of how impact cratering works. The Linn crater fits the bill perfectly. By looking at the data from LRO's LROC instrument, scientists have confirmed that it has remained largely untouched aside from normal wear and tear, which is what makes it so perfect for comparison. They've also discovered some interesting and unexpected things. For decades, lunar scientists counted on the simplest craters, like Linn, as being bowl-shaped. However, thanks to the new data, scientists have discovered that they actually resemble an upside-down cone. This, along with other findings, sheds new light not only on Linn crater, but also on the evolution of similar craters on the Earth, Moon, and other planets, allowing us to get a better picture of our own history. In fact, the simple shape of Linn, and the way large boulders are strewn around its rim, are the basic tools of forensic geology that allow scientists to understand how craters start out on the Earth and Mars before water and wind wear them away. Without craters like Linn on the Moon, we wouldn't know how landforms evolve over time in the presence of weather, climate change, and other factors. And all by looking at what initially appears to be just another hole in the ground.